Welcome everyone. The lesson today is to simplify radicals containing imaginary numbers. We do have 5 examples, but in between that, even just before example number 1, I need to give a definition of what imaginary numbers are. Okay, it is assumed before this lesson that you know how to simplify radicals, square roots, and cube roots as well. So brush up on that if you're not good at that one just yet. But anyway, since you guys are here, let's already get started with a pre-step. Before we do example number 1, let's start off with x squared is equal to 9. Well, this is an Algebra 1 question already. To get rid of the square, the undo of that is what? Square root. So we're going to square root both sides. Okay, so what that means, one answer for x is going to be 3. So square root of 9 is 3. Does that make sense? Yes, it does, because 3 times 3 is equal to 9. And so that's okay. Alright. Suppose now, let's just go down along the line. We have square root of 4. Well, one answer to that is going to be 2. Does this make sense? Yes, it does, because what is 2 times 2? And that's 4. Okay. We can even go as far down as square root of 0. If we do square root of 0, what is that? That's going to be 0. That's because 0 times 0 is 0. Okay, take a notice of these numbers. These numbers are the same. 3 and 3, 2, 2, also 0 and 0 right over here. The only problem is if we go down the negative root, such as the square root of negative 1. Let's take a look at that. Well, we can try negative 1 times 1. That's equal to negative 1. The problem with that is these two are not the same as these right over here. We can even do 1 times negative 1. That's also negative 1, but we still come out to the same dilemma. So when we go into the negative root, that's where we are going to have a problem with this. Okay, we cannot find two numbers multiplied together to make negative 1, and they have to be that same number. Okay, so with this dilemma, what we're going to do is fix this by doing a definition of imaginary numbers. So here's your definition. If I squared is equal to negative 1, okay, and then to get rid of that square, we square root both sides. Then when we square root both sides, I is equal to the square root of negative 1. So this is a little bit more formal of a definition, but the important thing with this definition is this part right over here. I is equal to square root of negative 1. This is your imaginary number. Okay, let's already do example number 1 following this. Example number 1 is this, square root of negative 9, and the instructions, I know I didn't put it, is going to just simplify this radical over here. It's almost the same as doing just normal radicals if this was a positive, but let's just do a simple one first. And here are your steps. You're going to split the negative number using negative 1, and I'll show you how after this. Afterwards, we're going to break that into two radicals, and then we are going to simplify. So this is what I mean by that first step. Split the negative number using negative 1. Well, negative 9, that's going to equal to negative 1 times 9. Okay. Alright, second step, we're also going to break this into two radicals. To do that, we're going to go square root of negative 1, or radical of negative 1, times radical 9. Alright, from here, simplify. Well, let's go back to that definition. What was square root of negative 1? Anytime you see square root of negative 1, you're going to replace that with the letter I, because that is your imaginary number. So anytime you see square root of negative 1, that is replaced by I. Well, we already know square root of 9. Just take the positive of that. Just take the positive answer and it will be positive 3. Alright, from here, just treat that as a variable like x, y, or z. So we're going to have to write it as 3i like this. So this is example number 1, square root of negative 9, and this is your answer, 3i. Example number 2 is the same. We're going to simplify this radical, square root of negative 50. Let's follow the same procedures as example number 1, where we're going to split the negative number using negative 1. So let's do that. So this is going to be negative 1 times 50. And then we can also put this into two radicals. This is going to be square root of negative 1, or radical negative 1, times radical 50. From here, we're going to simplify. Let's see if you guys still remember. Anytime you see square root of negative 1, what letter is that? Yes, it's going to be I. And then from here, 50, this is the one we need to find pairs because it is a square root. Well, one way is to break this up as 25 times 2. Well, if you already know 25 is 5 times 5, then we already have a pair right over here. We're only going to bring one of them out of the radicals. So this is going to be I times 5 radical 2. I like this example because we have a whole number, we have the imaginary number I, and we have a radical. To write this, you're going to put the whole number first, 5, and then the I, and then the radical 2. So anytime you are multiplying these three things together, you need to put the whole number first, followed by the imaginary number, and then always put that radical or that square root last. So 5i radical 2, this is your answer for example number 2. Here is example number 3. We have an expression, radical 48 minus square root of negative 28. So we're just going to keep simplifying until we can't do any more. So let's already start with the 48. Well, the 48, we can go 16 and 3. And then from that 16, we can break this down into 4 and 4. I already see a pair right over here. We're only going to bring one of them on the outside. So this is going to equal to, I'm just going to put some space over here, 4 radical 3. So that radical 48 transforms into 4 radical 3 down below over here. The 3 goes inside the radical because it has no pair. Minus, well, let's follow the same procedures as examples number 1 and 2 when we have a negative under a square root. We are going to go negative 1 times 28. Okay, let's follow that along by separating them into two radicals. Alright, anytime you have square root of negative 1, that is the letter I. So I'm just going to put this in green marker over here. Kind of funny, it doesn't even look like an I. So that's an I. Okay, 28. This is going to be 7 and 4. And then that 4, you can break that down into 2 and 2. So that means that this is going to be I times, I know this is, probably don't have enough space over here. This is going to be I times 2 radical 7. Hopefully you guys could see that right over here. And then from there, just like in example number 2, whenever you have an I, whole number, and that radical, you're going to write it like this. This is going to be 2I radical 7. So you put the radical last, whole number first, imaginary number in between. So we've already simplified square root of negative 28. We're just going to have to just bring that one down. 4 radical 3 minus 2I radical 7. We can't combine these because they have different radicals. And so this is your answer for example number 3. Before we jump into the last two examples, I want to do a pre-step first, just a little recap on cubes. So say for example we have negative 2 to the third power. Well, that's gonna, let's just expand this. This is going to be negative 2 times negative 2 times negative 2. So be careful, negative 2 times negative 2 is positive 4, but then you multiply that back again to a negative 2, so that becomes negative 8. So negative 2 to the third power is negative 8. Why are we doing this? Because this is going to be important for the last two examples. Okay, let's just go maybe 3 or 4 more of these. Negative 3 to the third power is going to be negative 27. Negative 3 times negative 3 is positive 9. Then multiply that back again to a negative 3. That's negative 27. Let's just list down 3 more. Negative 4 to the third power is negative 64. Negative 5 to the third power is going to be negative 125. and then negative 6 to the third power is going to be negative 216. I think you get the point that every time you have a cube and there's a negative inside, that your product is going to come out negative because you're multiplying that negative 3 times. Okay, so that's going to be very important for these last two for this lesson. So let me bring out example number 4 right now. Okay. This is example number 4, simplify. So we're now going to cube roots. So this is a cube root right over here. This means that in order to bring some of these numbers out, we need to find a triplet. Okay, cube root of negative 250. Now the first 3 examples, we've been doing it so that anytime we had a square root and there's a negative on the inside, that we're going to have to use imaginary numbers. But is it the case for cube roots over here? And the answer is no. Some problems, just like the cube roots, may look like they have imaginary numbers here, but they really don't. And this is what I mean. So let's already start simplifying this one over here. This negative 250, I'm going to rewrite it so that we can go negative 125 times 2. So I'm just breaking it down right now. Now this is the reason why we had to review some cubes, because we do find a triplet with a negative 125, and that triplet is negative 5 times negative 5 times negative 5. Why is that so? Because negative 5 parentheses cubed is a negative 125. So we've already found our triplet right over here. We didn't even have to use I in this case. How many of these are we going to bring out? We're just only going to bring out one of them. So that's going to be negative 5. So that goes out. Cube root of what's left under the cube root is the 2, because it does not have a triplet. So this is your answer for example number 4. So again, the point is, even though you have a negative under a cube root, you may not have to do I, because you may find a triplet pair that contains those negatives already. So be very good at spotting those negative cubes, those triplets. And so we're going to conclude this with example number 5 right now. Here's the last example for this lesson on imaginary numbers. A cube root of negative 135 x to the 4th y to the 5th. This problem is very similar to the last example, where it may look like we need imaginary numbers, but we don't. Okay, well, here's a 5. Let's start breaking down the numbers over here first. Since I spotted a 5, I'm going to divide this by 5. So I've already done this for you guys. This is going to be 5 times negative 27. Now this negative 27, hopefully you can spot this as a triplet, because this negative 27, you can go negative 3 times negative 3 times what? That's right, that another negative 3. So we've done that on the pre-step already. Found a triplet right over here. Alright, I'm going to spread out, I'm going to expand the x to the 4. That means that we have 4 x's, 1, 2, 3, 4. And that y to the 5th, we have 5 y's, 1, 2, 3, 4, 5. Remember, we're not dealing with square roots, we're dealing with cube roots. That means that we're going to take this triplet right over here, and I spot another triplet of y right over here. Okay, remember, after you spot those triplets, you're only going to bring out one of them outside that cube root. So only take out 1 times x, only one of those, and then times y. Now the cube root, well, what's left under the cube root? Well, the ones that do not have those triplet pairs. So that 5, lonesome right over here, that 5 goes inside over here, as well as that x right over here, didn't have a triplet, and those 2 y's. So those 2 y's, we're just going to write it as y squared. Anytime you bring out numbers on the outside, you're just going to multiply them together. So this is a simple multiplication. This is going to be negative 3xy cube root of 5x y squared. This is your final answer for example number 5. To wrap up the lesson on imaginary numbers in general, whenever you have, number 1, negative numbers in square roots like this, or in this simple radical over here, you will most likely have imaginary numbers. So please go back to examples numbers 1, 2, and 3 on that. However, like the last two examples, 4 and 5, watch out for cube roots, because you may not have imaginary numbers if you have a negative inside that cube roots. It may be something like negative 3 times negative 3 times negative 3, which is negative 27. Under that cube root, you don't need imaginary numbers with that. So please look over back on those two examples number 4 and 5. So this is the recap for this lesson on imaginary numbers.